There is a moment in human history that almost nobody talks about. A moment when the world ended. Not in myth, not in metaphor, literally, physically, in a way that left its signature in ice drilled from Greenland, in lake sediments from North America to Europe to the Middle East, in the bones of animals that died in enormous numbers at exactly the same instant in time, 12,800 years ago. Temperatures in the Northern Hemisphere dropped by as much as 15 degrees Celsius, not over centuries, within decades, within years. Some evidence suggests within months. Glaciers that had been retreating for thousands of years reversed. Forests that had grown for millennia died back. Species that had survived multiple ice ages simply vanished from the earth. And somewhere in the middle of all of that, in the chaos of a world changing too fast for anything to adapt, there may have been people. Not primitive people huddled in caves, people who understood the sky, who built things, who carried knowledge that would take the rest of humanity thousands of years to rediscover. People who left almost no trace, because the world that carried their traces was burned and drowned. What happened 12,800 years ago? That question, simple to ask, almost impossible to answer, is where tonight's story begins. The world before. To understand what was lost, you have to understand what existed. Sea levels were approximately 120 meters lower than today. That doesn't sound dramatic until you trace the implications. The North Sea between Britain and Denmark was a plain. A landmass called Doggerland stretched across what is now open water, home to rivers, forests, and human communities whose artifacts North Sea fishing trawlers have been pulling up by accident for decades. A carved antler harpoon point, found in the nets of a fishing boat and dated to more than 11,000 years old. Stone tools, mammoth bones, the remnants of a world that was simply there and then wasn't. Doggerland was not marginal tundra. It was productive. A rich estuarine environment with abundant fish, game, and plant resources. Exactly the kind of place where human populations concentrated. All of it is now under the North Sea. Southeast Asia was unrecognizable. The islands we now call Sumatra, Java, and Borneo were part of a single enormous landmass, Sundaland, roughly the size of India. Warm, tropical, productive, connected to the Asian continent. The Persian Gulf was a river valley. The Tigris and the Euphrates ran through it, down to an Indian Ocean coast that was hundreds of kilometers further south than it is today. These drowned landscapes were not marginal zones. These were some of the most resource-rich, most habitable environments on Earth. They are now completely underwater. And if something remarkable was happening on those coastlines before 12,800 years ago, we would expect to find almost no physical evidence of it. Not because nothing was there, but because everything that was there is now sitting on the bottom of the ocean, under decades of sediment, beyond the reach of conventional archaeology. That is the first mystery. And the second one is what ended it. What happened? The Younger Dryas cooling is documented beyond any reasonable doubt. The Greenland ice cores show it with startling clarity. The oxygen isotope record, essentially a thermometer reaching back in time, captures the transition in layers thin enough to count annually. What the cores show is this: the warming that preceded the Younger Dryas had been gradual, consistent, steady for thousands of years. And then, within what appears to be a matter of years, possibly 3, the temperature of the North Atlantic dropped by 10 to 15 degrees Celsius. Think about what 3 years means on a human scale. You could be 40 years old and watch the world change. Watch the winters stop ending. Watch the animals leave and not come back. Watch the growing seasons shorten until they barely exist. Your grandchildren would be born into a world you no longer recognize. That is what the Younger Dryas looked like from the inside. 1,200 years of it. The conventional explanation for what triggered this collapse is a glacial lake outburst. An enormous reservoir of meltwater, Lake Agassiz, covering much of central North America, discharged catastrophically into the North Atlantic. Cold fresh water diluted the salt ocean, shut down the circulation that distributed warmth across the hemisphere, and the cooling cascaded. It's an elegant explanation. It fits much of the data, but it doesn't explain the black layer, and the black layer is where everything gets strange. The evidence? At sites across North America, there is a specific layer in the geological record. Thin, dark, rich in carbon and ash. Below it, mammoth bones, stone tools, the normal signatures of a functioning ecosystem. Above it, almost nothing. A silence in the pollen record, an absence of megafauna, the disappearance of an entire human culture. The Clovis people, the dominant culture of pre-Younger Dryas North America, known for their distinctive, beautifully crafted stone tools, simply vanish at this layer. Not evolved, not replaced gradually. Gone. Above the black layer, the cultures that appear in North America are different. Different tools, different patterns. As if the people who made Clovis points were simply no longer there. For decades, researchers assumed the black layer was ash from wildfires triggered by the climate change itself. Then in 2007, a team of researchers from multiple universities published a paper in the Proceedings of the National Academy of Sciences. They had analyzed the black layer in detail, and what they found inside it should not have been there. Nano-diamonds, microscopic diamonds that form only under the extreme pressure and temperature of a cosmic impact. Platinum group elements, metals vanishingly rare on Earth's surface but far more common in extraterrestrial material. Magnetic spherules, shocked quartz, melt glass. These materials were found not at one site, at dozens of sites across North America, then Europe, then the Middle East, then South America and South Africa. The same layer, the same materials, the same moment in time. On 4 continents simultaneously. Let's be specific about what that means. Nano-diamonds don't form in wildfires. They form under pressure and temperature conditions that require either a cosmic impact or a nuclear explosion. There were no nuclear explosions 12,800 years ago. Platinum is among the rarest elements on Earth's surface. It is found at the Younger Dryas boundary in concentrations 10 to 20 times higher than the background level. The same platinum spike that appears in lake sediments across North America appears in Greenland ice cores, ice that fell as snow, high in the atmosphere, far from any volcanic source. The platinum didn't come from the ground, it came from above. And melt glass, the most recent and most striking piece of evidence, was found at Abu Huraira in Syria, formed at temperatures of approximately 2,200 degrees Celsius. Normal wildfires burn at 900 to 1,100 degrees. Nothing in ordinary human experience produces glass at 2,200 degrees. The researchers concluded it could only have formed in an airburst, a cometary fragment exploding directly above the site. an airburst over Syria. At exactly the moment the Younger Dryas began, in the heart of the region that would, a few thousand years later, produce the world's first known urban civilization. This is not what a glacial lake outburst looks like. This is what a cosmic impact event looks like. The comet. A comet or asteroid enters the inner solar system. It is already fragmented, broken apart by gravitational forces, or it breaks apart as it approaches Earth. The fragments spread along the orbital path. They don't all hit the ground. The 1908 Tunguska event in Siberia, a single object perhaps 60 meters across, exploded in the atmosphere without leaving a crater and flattened 2,000 square kilometers of forest. Now imagine not one Tunguska, 100 of them, spread across North America, exploding in the upper atmosphere simultaneously. The thermal pulse ignites forests across entire regions. The smoke and soot rise into the stratosphere and block sunlight. The thermal energy concentrated over the Laurentide ice sheet destabilizes it, triggering the catastrophic meltwater pulse that shuts down ocean circulation. Fire, then cold, then flood. All three, in a sequence that, to anyone who lived through it, would have looked like the end of the world. In 2018, researchers announced the discovery of a massive impact crater beneath the Hiawatha Glacier in northwestern Greenland. 31 kilometers in diameter, formed by an iron asteroid more than a kilometer across. The edges were fresh, sharp, unsmoothed by erosion, in ways suggesting a geologically recent origin. Dating attempts have been inconclusive. The crater might predate the Younger Dryas by thousands of years. It might not. But its existence, a major impact crater in exactly the part of the world where the Younger Dryas was most severe, cannot be easily set aside. And it raises a question that nobody has answered. If there's one crater, are there others? Did a fragmented comet deliver multiple impacts across a wide area? Is that what the black layer represents? Not one event, but a distributed catastrophe that rained down across an entire hemisphere? There is a specific candidate for the impactor that some astronomers have identified. The torrid meteor stream. Twice a year, Earth passes through the debris field of a disintegrated comet, a field that includes objects ranging from tiny pebbles to bodies hundreds of meters across. Most passes are harmless, but the torrid stream contains denser regions where the objects are larger. And some researchers have calculated that Earth passes through the most dangerous part of the torrid debris field on a cycle of thousands of years, a cycle whose timing aligns with the Younger Dryas. If that calculation is correct, the catastrophe of 12,800 years ago may not have been a once-in-a-billion-years event. It may have been a once-in-a-few-thousand-years event. And Earth still passes through the torrid stream, twice a year, every year. The same debris field that may have ended the Ice Age world is still there, still intersecting our orbit, still in its denser regions, containing objects large enough to matter. We are not outside the story of 12,800 years ago. Not entirely. We are downstream of it, and the question of how far downstream we are is one that astronomers are only beginning to seriously investigate. The debate. The Younger Dryas impact hypothesis is one of the most contested topics in contemporary science. The criticisms are serious. Some of the impact markers, particularly the nano-diamonds, have been challenged on methodological grounds. Attempts to replicate the original findings at some sites returned negative results. The spatial distribution of the evidence is unusual for any single impact source. These are legitimate objections. But the evidence has not gone away. By the time a comprehensive review was published in 2018, co-authored by more than 40 researchers from 22 institutions across 15 countries, the number of sites where the boundary layer had been confirmed, with at least some impact markers present, had grown to over 50. 50 sites, 4 continents. In 2020, a team reanalyzing samples from Abu Huraira in Syria found melt glass at the Younger Dryas boundary that had formed at temperatures of approximately 2,200 degrees Celsius. Normal wildfires burn at 900 to 1,100 degrees. Nothing in ordinary human experience produces glass at 2,200 degrees. The researchers concluded it could only have formed in an airburst, a cometary or asteroidal fragment exploding above Syria. Critics maintain that alternative explanations exist for many of the impact markers. But here is the core question that neither side has fully resolved. If it wasn't an impact, what produced that layer of nano-diamonds and platinum and shocked quartz and melt glass in synchrony across 4 continents at exactly the moment the Clovis culture disappeared and the Younger Dryas began? That question does not have a satisfying conventional answer. Could a civilization have been lost? This is where the investigation moves into territory that mainstream archaeology finds deeply uncomfortable. And it is a question that, if you follow the evidence honestly, is almost impossible to avoid. The conventional timeline of human civilization places the first complex societies in Mesopotamia and Egypt, roughly 5,000 to 6,000 years ago. Agriculture began around 10,000 to 12,000 years ago. Conveniently, this is almost exactly when the Younger Dryas ended. The transition from catastrophe to civilization happened very fast. Suspiciously fast, some argue. And then there is Göbekli Tepe. The oldest layers of Göbekli Tepe date to approximately 9,600 BCE, roughly 11,600 years ago. The Younger Dryas ended approximately 11,700 years ago. 100 years. Göbekli Tepe was being built 100 years after the worst of the catastrophe was over. The site is a complex of massive stone enclosures, elaborately carved with animal imagery, built by people who, according to the conventional model, should not have had the organizational capacity to build it. And here is the detail that never fully fits the conventional explanation. The oldest phases of Göbekli Tepe are the most sophisticated. The later phases are simpler. This is not how emerging technologies behave. When a culture is learning to build, the early work is crude, and the later work is refined. You start primitive and get better. The story of every technology humanity has ever developed runs in that direction. Göbekli Tepe runs the other way. The very first enclosures, the deepest, the oldest, contain the largest pillars, the most detailed carvings, the most precisely planned layouts. The later enclosures, built by the people who inherited the tradition, are smaller and simpler. The tradition was not developing, it was declining. Something knew how to do this before Göbekli Tepe. Something came before it. And whatever that something was, it didn't survive the Younger Dryas intact. It survived in fragments, in diminished form, in the hands of people trying to rebuild something they only partially understood. Graham Hancock has spent 3 decades arguing that the Younger Dryas catastrophe destroyed a civilization that had reached genuine sophistication. Not necessarily cities and writing in the way we recognize them, but real astronomical knowledge, real mathematical understanding, real navigational capability. He points to astronomical alignments at Göbekli Tepe, to the Sphinx's erosion patterns, which some geologists argue indicate rainfall that ended thousands of years before the pharaohs, to the precision of ancient monuments worldwide, many of which encode knowledge of the precession of the equinoxes, a 26,000-year celestial cycle that requires generations of careful observation to detect. Precession takes millennia to measure. The oldest civilization we have detailed records of is about 5,000 years old. So how did ancient cultures possess accurate knowledge of a 26,000-year cycle? The conventional answer: they figured it out through patient observation over centuries. Hancock's answer: they inherited it from people who had been observing the sky for a very long time before the catastrophe. Critics respond with the fundamental objection: where is the physical evidence? If an advanced civilization existed before the Younger Dryas, there should be ruins, tools, graves, detritus. Supporters respond: it's underwater. The coastlines where sophisticated Ice Age populations concentrated are now beneath 120 meters of ocean. We have not looked there, not systematically, not with the resources the question deserves. This is not a debate that has been resolved. It is a debate that has been avoided. And the frustrating truth is that we cannot determine, from current evidence, whether Hancock is right or wrong. What we can say is that the places where the evidence would most likely be found are the places archaeology cannot currently reach. The deeper question. There is one more thread worth following before we close. The flood myths. Every major ancient culture has one. Mesopotamia, India, China, the Americas, the Pacific Islands. A catastrophic inundation, a world destroyed by water. Survivors who escaped and rebuilt. The structural similarities between these myths, across cultures with no documented contact, have always been a puzzle. Some scholars see coincidence. Floods are universal. Catastrophe mythology is a natural human response. Others point to a specific piece of evidence that changes the conversation. Aboriginal Australian oral traditions had been shown to preserve accurate geographical information about specific coastal features, specific bays, specific river mouths, specific islands that were drowned by sea level rise more than 7,000 years ago. Not vaguely, specifically. The geographical details in these oral traditions match the actual geological record of coastal change. 250 generations of transmission, and the landmarks are still recognizable. This proves something important. It proves that human oral traditions can preserve accurate geographical and historical information across enormous timescales. If Australian traditions preserve coastal geography from 7,000 years ago, why would Mesopotamian traditions not preserve memories from 12,000 years ago? If the flood myths encode genuine memory, however distorted, however mythologized, of the catastrophic coastal flooding at the end of the Ice Age, we are looking at cultural memory from the time of the Younger Dryas itself. And then there is this. Plato said Atlantis was destroyed 9,000 years before his time. that places the destruction at approximately 9,600 BCE. The Younger Dryas ended at approximately 9,700 BCE. Plato's date for a legendary catastrophe corresponds almost exactly to the actual geological date of the most catastrophic sequence of events in post-Ice Age human history. Coincidence? Maybe. Or maybe the story was older than Plato, older than Greece, carried for thousands of years through cultures we can no longer name, arriving in Athens already ancient, already mythologized, but still pointing, however imprecisely, at something real. We don't know. We genuinely don't know. Conclusion: something happened 12,800 years ago. The evidence for this is not speculative. It is documented in the most detailed archives we have: Greenland ice, continental sediments, the chemical signatures of materials that should not exist in 12,000-year-old layers. The Younger Dryas was real, rapid, devastating. The impact evidence: nano-diamonds, platinum anomalies, melt glass at temperatures only airbursts can produce, confirmed at over 50 sites on 4 continents, is real and growing. The megafaunal extinctions were real. The collapse of Clovis culture was real. The questions are real. What triggered the Younger Dryas with such terrifying speed? What deposited those impact markers in synchrony across an entire hemisphere? What happened to the people who were living on the coastlines that are now underwater? What were they doing? What did they know? And what did we lose? These questions matter, not just as history, as warning. The forces that produced the Younger Dryas have not gone away. The sky that sent something into the atmosphere over North America is the same sky overhead right now. The ice sheets that melted when the temperature changed are still melting. The coastlines that drowned when the seas rose are a warning about coastlines that could drown again. We are not outside the story of 12,800 years ago. We are downstream of it. And the question of what our ancestors survived, what was lost so that we could exist, is not just a mystery about the past. It is a question about how fragile civilization really is, how easily it breaks, and how long it takes to rebuild what was lost, if it can be rebuilt at all.